Hi students, today in elimination reactions we are going to discuss what is saytzeff rule and Hofmanns rule. So first let's discuss what is saytzeff rule. So in some elimination reactions we can see more than one product is formed. So more than one elimination product is formed. So one may be minor product, one may be major product. So according to saytzeff rule, what is that? We'll discuss. Here most substituted product will take, and alkene is the major product here. So let's discuss first with one example. So let's see here. So we are removing alkyl halide in the presence of alcoholic KOH base. We already discussed in the elimination reactions, we use a base for the elimination reactions, and where the halogen is present, it is a alpha carbon, and beside it is beta carbons. This is a beta carbon and this is a beta carbon. So the hydrogen or proton can be removed from any of these two. So when the proton is removed from this beta carbon, so what happens? So we'll get a minor. So here we'll get a double bond. See, from this alpha carbon, X is removed with the help of KOH. K reacted with X to form KX, and this proton or hydrogen is removed to give double bond here, and water molecule is removed. So here, and one more product we can see from this beta carbon. So the hydrogen or proton is removed to get double bond here, and as usual the halide is removed, and this is major. How we can consider whether it is a major or minor? So very simple trick is, so the elimination of hydrogen from beta carbon which have least number of hydrogens is a major form, or it is a most substituted form. So here when we see this beta carbon, 2 hydrogens are there, and here 3 hydrogens are there. So this beta carbon have less number of hydrogens. So when the hydrogen or proton is eliminated from the beta carbon which contain least number of hydrogens, then it is the major product, or we can say it is the most substituted product. And when the proton is removed from the beta carbon which have more number of hydrogens, it is a minor form or least substituted product, we can say. So we'll get 2 products, major and minor. So this saytzeff rule predicts the regioselectivity of olefin formation. So while forming the olefin, means alkenes, so it predicts regioselectivity. So from which region it selects to remove the proton. So we can define like this the saytzeff rule. Saytzeff rule states that if there can be more than one adjacent carbon, if the more than one adjacent carbon to the alpha carbon, then the proton is eliminated from the carbon bearing the least number of protons. So when the proton is removed from the least number of beta carbon which contain least number of protons, then it is a major form. So like this we can discuss. One more example I am giving to make it easier. Here the same example I took. So CH, CH3, CH2, CH3. So this is alpha carbon atom, this is beta carbon, and this is beta carbon. So which contain less number of hydrogens? Here 3 are there, here 2 are there. So this is containing less number of protons. When the hydrogen is removed or proton is removed from this, and if we get double bond here, then it will become so it is a butene. 1 2 3 4 carbons are there. It is a butyl chloride. So when we remove hydrogen chloride, so what happens? It will become butene. So double bond will come here. So this place double bond came, and 1 2. So near to the second and third carbon, so it is a 2-butene, and it is a more stable form. So and this one is 1 butene. So here here it is formed because more carbons are there, and so it is a minor form. So we can say sometimes we can get them. In all the times, is it applicable or not? So saytzeff is not applicable in all the cases. Why? Means due to the steric effect during the elimination reaction. So this is about saytzeff rule, and then we will discuss Hofmann's rule. It is exactly opposite to the saytzeff rule, Hofmann's rule. We will see. Here in saytzeff rule, I told the product is more stable form, will get more substituted form, most substituted form. Here the least stable alkane will get. So again I am taking one example here. So CH3, 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 CH2, CH, CH3. So here this is halide place, it is alpha carbon, these two are beta carbons. So here where more hydrogens are there, more protons are there, this carbon, this beta carbon. So when we substitute here, we'll get the so like this, here we'll get double bond. So when here it is substituted, we'll get here double bond. So least substituted alkane is the major form. So we can tell, so actually here it is the less carbon atom, so and it should be the major, but opposite of this is major form. So opposite of saytzeff rule, and this is minor form. So least substituted alkane is major, and the elimination of proton from the carbon which has maximum number of hydrogens. So here it contains maximum number of hydrogens, so it is major here. So opposite of saytzeff rule, just remember this. Then one more example I am giving, NN dimethyl. So N dimethyl, N ethyl and propyl amine. So when we this is a salt, hydroxide salt. When we heat it, what happens? The breaking of bond here it will take, and it will give alkene, ethylene it gave. So how it takes place, mechanism? First what happens, the hydroxide ion abstract a proton from beta carbon, so which is a beta carbon. So when we take it is a beta carbon. So from the beta carbon resulting in a double bond formation. So the proton from here it will take off to form water molecule OH water molecule, and it will result in the formation of double bond here. So when the double bond formed here, so here charge will come, so that it will be separated. So CH2 double bond CH2 plus NH2 CH3 twice and propene we wrote, and water molecule is removed. So here also, here less substituted alkene is formed, so it contain more hydrogens. So when we see here, it contain more hydrogens than this one. So here the proton is removed, so less substituted alkene is formed. Because why it is forming like this? Because of the inductive effect of alkyl group, because of the inductive effect of the alkyl group. So we can say that Hofmann rule states that charged substrates like quaternary ammonium or sulfonium salts will yield less substituted alkene. So this is a less substituted alkene. So like this we can say saytzeff rule and Hofmann's rule. In the next video I'll explain when to apply saytzeff rule, when to apply Hofmann's rule. Thank you.